Okay, welcome to your first video for the Algebra 2 class. Hopefully you have your notes out from section pre-unit 1, which is functions, domain, and range. We're going to go over the first 2 pages of this, and then we'll do the next page in class, the part about domain and range, because that's a little bit more of a difficult concept, and I want to make sure that I'm able to answer your questions. Couple of little suggestions before we get going. The first suggestion I would make is always make sure that you do have your notes out and follow along with your notes and write things down as I write them down. Don't forget, since this is a video, you can stop and pause it if you need to. And also, since it's up on YouTube, you can play this thing at 1.25 speed in a little settings button, or you can do it as fast as 1.5. 1.5 might be a little too fast to follow, but if you want to save yourself maybe a couple minutes, if you play it on 1.25, you should still be able to understand everything. So hopefully this works out for you, and here we go. Alright, so before we start diving into things in the book, we need to backtrack and learn about some concepts that are assumed that you know. And the reason you guys don't know these things yet is because we're transitioning from the old system to the big ideas. And so if you have a sibling or a friend who's a 9th grader, you may see them running into this sometime this semester or next semester. But since you didn't have that opportunity, we're going to show it to you now. And this is going to happen off and on throughout the semester, both this year and for next year's Algebra 2 class until we get through the full transition. So don't be upset if you see some things in this class that you see in your Algebra 1 class. It's just a matter of the whole transition process. So let's talk about what a function is, and then also how do we look at something and determine it's a function, and then also just some notation and evaluation of functions. It's really not a difficult concept. It's not anything really dramatic or new from what you're used to. The main thing I would recommend that you keep in the back of your mind is when we're talking about functions, we're talking about equations. We're just talking about a subset of equations that follow some special rules. And what that rule is, if we look at the definition of a function, it's basically it's a rule or an equation that assigns each value of one variable exactly to one variable of another. So let's go ahead and write that down. So what do we got? We got a function is a rule, and remember, anytime when we're talking about a rule in math, essentially we're talking about an equation. Not always, but in Algebra 2, a rule equation, I'll use those two words synonymously. And what does it do? It's going to assign to each value of one variable, one, in this case the x value, okay, because remember in equations we talk about x's and y's, to exactly one value of another variable. To exactly one variable. Oops, let's change that to exactly one value of another variable, y. Okay. Now, what does that big definition mean? Basically, what it means is that if I take an equation and I pick a number for x and I plug it into the equation, I'm going to get one answer. I'm not going to get 0 answers. I'm not going to get 2 answers. I'm going to get one answer. Exactly one answer. Those are your keywords, exactly one. Okay? So, layman's definition here, substitute a number in for x. So you substitute a number into the equation for x, and you get one answer for y. Oops, running out of room down there. Okay, that's all it is. Okay, if you run into an equation where you plug one answer in for x and you get one answer back for y, we call that a function. It's a subset. Okay, So let's take a look at these four things and let's determine if they are functions. Okay. One of the easiest ways to do that is you just simply pick a number. Pick a number for x. Okay. So let's say in this case x equals 3. Well, what happens when we plug x equals 3 into that equation? We get 3 times 3, substitute in right there, and then we got our plus 2, we get 9, 11. Y equals 11. Notice I plugged one number in for x, I got one answer for y. Continuing on that process, for this next one, let's say x equals 2. And what happens when I plug 2 in there? We get y equals 2 over 2, or y equals 1. Once again, notice, plug one answer in for x, get one answer in for y. Similarly on this third one, let's say x equals, I don't know, we'll say 4. Okay. What happens when I plug y in there? I get 4 squared. Or excuse me, when I plug x in there, I get 4 squared. And I get y equals 16. Once again, plug one number in for x, get one answer for y. Right? Now, are these three functions? The answer to this is yes. Yes, this is a function. Plug one number in, get one number out. Yes, this is a function. Plug one number in, plug one number out. Yes, this is a function. Plug one number in, plug one number out. This other one though, let's take a look at it. Okay? So we got y squared equals x, and this is actually one that's not a function, so let's see how it's different. So what do? We got to pick a number for x. Let's pick one that's going to be easy. So let's go with 25. Okay? And so now when I substitute 25 in there, notice I get y squared equals 25. So remember what squaring is. Basically, the idea of squaring something is you're saying what number times itself equals 25. And if you think about it, 5 times 5 equals 25, so that's one possible answer for y. But also -5 times -5 equals 25. Okay, so you can see just thinking about it, there's two answers. Now how do we do this mathematically? Well, if we have y squared equals 25 and we want to get y by itself, remember we square root. And we square root both sides. And hopefully your Ag 2 teacher taught you that anytime you introduce a square root into an equation, you got to do the plus or minus, which means the positive version of the answer and the negative version of the answer. So anyway, y squared, when we square root that, we get y. When we square root 25, we get the plus or minus 5, which means we have two answers here. Y equals positive 5, y equals -5. Notice what happened in this one is in comparison to the other three. The first three, we took one number, plugged it in, we got one answer back. Here, we took one number, we plugged it in, and we got two answers back. 2 is not exactly 1. If I were to get 0 answers back, okay, same thing, 3 answers back, 4 answers back. The only way this can be a function is if we have exactly one answer. And we don't, so we say no. Okay? Now, these are just simple examples of functions and not a function. How can we tell by looking at an equation? An easier way to look at an equation and determine it's a function. The easiest way to do this is this thing called the vertical line test. Okay? And it requires a little bit of graphing, and then you do this vertical line test. So, here's basically the idea behind the vertical line test. The first thing you want to do is draw vertical lines on your graph of your equation. So you're going to graph the equation, you're going to look at it, and you're going to either literally or just in your head draw vertical lines. Okay? Up and down. The rule for the vertical line test, it says that the equation is a function if the vertical line crosses the graph exactly once. The vertical line Ooh, I'll fill in right here. Crosses graph exactly once. Okay, so see there again, once again, you got the exactly once piece. All right, so let's take a look at these examples right here, and let's graphically determine if they're functions. Okay, and how I'm going to do it today is I'm going to use the Desmos graphing calculator, which there's a link to it on the Algebra 2 website. Tomorrow we'll talk about how you can graph these things on the TI-83 graphing calculator, because for testing you're going to have to be able to use the TI graphing calculator. Can't use Desmos on a calculator. So we'll show you both ways, and we'll go with that. Alright, so here I am at the Desmos calculator. I've already entered the four equations ahead of time. So let's look at the first one, which is y equals 3x plus 2. And when we graph that, let me see if I can make it a little bigger here. When we graph that, hopefully you can just eyeball that and notice that's a straight line. Now, if I draw a vertical line anywhere on here, if I draw a vertical line here, I touch the graph once. And you can kind of see the grid of vertical lines. Each of these vertical lines touches the graph exactly once. It's okay they touch in different spots, but each individual line touches once. If that's the case for the entire graph, we have a function. So, y equals 3x plus 2 is a function. So very simply, is it a function? Yes. Okay. Looking at the next one, shut this off, turn that one on. Okay, let me zoom out a little bit here. Okay. This is actually called a rational equation, rational being a fraction. We're going to study these a lot later on. Now, what happens to this piece of graph right here? You can see it's going to go down. It's going to keep continuing going down forever, getting closer and closer to the y-axis, but it will never cross over it. Same thing up here. This piece will go up, 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 get really close to the y-axis, never touch it. Same thing here for the x-axis. Same thing here for the x-axis. So these graphs never actually cross over any of the, this graph, I should say, never crosses over any of the axes. So let's take a look at our vertical lines on the grid. If I draw a vertical line right here, how many times does it touch? Once. Over here, touches once. Okay. Over here, touches once. Over here, touches once. You can see it always touches once. Is this a function? The answer to that is yes. Alright, so let's throw a yes in there. Alright, the third one, y equals x squared. We're going to be studying these graphs a lot also. This is called a quadratic function. Quadratic meaning it has a squared as its highest power. Alright, x squared. You zoom in on that one a little bit. Is it a function? Yes or no? Look at your vertical lines. How many times does each vertical line touch the graph? Got once there, once about there, once about there. Y-axis touches right there. So each one touches only once. So yes. Okay. What about this last one? Let's go ahead and take a look at this last graph. Boom. Let me get it where we can see it. Look at our vertical lines. If I draw a vertical line right here, hits once, hits twice. If I draw a vertical line here, hits once, hits twice. Okay? It hits more than once. Does not hit exactly once. Therefore, it is not a function. Okay? So using the vertical line test is a quick and easy way to look at a graph and say function, not a function. Remember, once again, what a function is. A function is a subset of all the equations in the world, where when you plug one number in, you get one number out. So you plug one x in, you get one answer for your y, as opposed to two, like up in this area. Okay, so that's the basic idea behind the function. Let's talk about some notation. And this is really simple. And we're talking about notation. It's just a way to, a symbol, a way to symbolize something, a way to mark something, a way to designate something as a function. Okay? And so we're going to say it's a special way because math is special, isn't it? Okay, a special way to write an equation. That classifies it as a function. IES, thank God I don't take any English. Teach English. Classifies it as a function. Alright, and here's the notation. The notation, instead of writing like y equals 3x plus 2, we replace the notation of y with this thing called f of x. That's how you read that. F of x. Okay? You can use the letter F. We often use the letter G also, which is G of x. And we also use H a lot also. Okay? So typically what that means, okay, for our equations, which we're now going to start calling functions, is that in the past you would write something like this. Y equals 3x plus 2. Now you're going to replace the y with f of x, or g of x, or h of x. So f of x equals 3x plus 2. Okay? These two things do exactly the same thing as far as when we plug numbers in or evaluate or substitute. They also do the exact same thing when we graph this. If I were to graph f of x equals 3x plus 2, here, let me show you that real quick. So f of x equals 3x plus 2. Notice that one right there. And notice when I click on that one, they're the same thing. They're the exact same thing. It's just different terminology. That's all function notation is terminology. So similarly, if I wanted to go y equals 5 over x, because it's a function, a special type of equation, a subset of all the equations, we can say g of x equals 5 over x. And similarly, for our third one, x squared, instead of writing y equals x squared, we can say h of x equals x squared. So all that is notation. As far as you're thinking, think equations. Right? So hopefully that's straightforward. Alright, last thing I want to cover. Evaluating functions. Substitute. Think about how you substitute things. How you evaluate things. Okay? And we're going to use the famous old t-chart. Okay? So, how do we evaluate this function? Given f of x equals 3x squared plus 4x plus 7, evaluate f of x for negative 2 less than or equal to x all the way up to positive 2. One thing I should have put in here is we're just going to evaluate for all the integers. And so the first thing I want to talk about is this notation over here. Negative 2 less than or equal to x less than or equal to 2. That basically means all of the integers from negative 2 to 2. So when we go to evaluate this for our t-chart, the first thing we have to do is list all of the integers that we're going to evaluate for. So let's go ahead and set up our t-chart. So the t-chart is going to have 3 columns. First column is going to be x. The second column, instead of y, we're going to say f of x. And my third column will be a place to set up and show our work. Now, what numbers are we going to use for x? We're going to use all the integers from negative 2 to 2. So negative 2, negative 1, 0, 1, and 2. 0, 1, and 2. So there's our t-chart. Now, if we want to evaluate them, what evaluate means is essentially I'm going to start with negative 2, and I'm going to plug it in there for x. Substitute. That's all evaluating is. So what does that look like? It's going to be 3 instead of x squared. I'm going to have negative 2 squared. Notice I put the negative 2 inside of parentheses. Anytime you substitute a number in for a variable, you put it in parentheses. All right, plus 4 times negative 2. Sorry, I'm bleeding over. Plus 7. All right, let's grab our handy dandy TI calculator. Where is it? I know where it's at. All right, let's go desktop. All right, look at that bad boy. Pretty cool, huh? All right, so let's clear that out. I'm going to plug this in exactly like it looks like. So we're going to go 3 times, for negative 2, use this key down here for the negative, as opposed to the minus. All right, negative 2, we got the squared button right there. Whoops, I forgot my negative 2. Let's back up. So negative 2, closing parenthesis, squared, plus 4 times negative 2, plus 7. All right, hit enter, get an answer of 11. Cool, now we got to do it for negative 1. But watch this, if you use the TI calculator, if you hit the second key and then enter, it brings up everything you just typed in. So now all I got to do is take my arrow key, go over to negative 2 and change that 2 to a 1. Change that 2 to a 1. And that's all the work I got to show. I've set my problem up. I don't need to show anything else down here. It's simple arithmetic at this point. 6 for 0, it's going to be 7. How do I know that automatically? Well, plug 0 in there, that whole thing's 0. Plug 0 in there, that whole thing's 0. And I just got 7. Little shortcut for you. For 1, hit second and enter. And I'll hit the delete key to get rid of that negative. Okay, difference between delete and clear. Clear would clear everything out and give me a blank screen. Delete just deletes that little mark that or wherever my cursor is. Hit that, we get 14. And change that to a 2. 2. All right, 27. Cool, we're done. We just evaluated it. Now, if I were to go ahead and graph this, what would I have? Negative 2, 11. There's my x, there's my y. There's my x, there's my y. And I'd graph all of those points. Draw lines in between them, call it good. All right, try this one on your own. We will go over it in class. Make sure you answer any questions that you might have. Yeah. That's it. So, with the exception, in case we have a little notes quiz, I think you guys need to know the answer to the question of that notes quiz. And the answer to the question is Diego. So write that down. All right? And you'll know what the question is.